Okay, what we're going to look at tonight is 6.4 here, sum and difference formulas. We're going to break this guy up into two different lessons here. So today's goal is just what are our formulas, how do we use them for some basic things, and then we'll start moving stuff around the unit circle and doing some more complex things tomorrow night. Okay? Now, here's kind of where we want to start. Okay, what values do we know exactly? Well, we know anything that is 30 degrees, that is 45 degrees, and that is 60 degrees, okay? And I guess you could throw in things with the 90s there, but realize those also come just from the 30s. So those are our special triangle values that we've been working with all year. So 60 is the same thing as a 120, is the same thing as a 240, is the same thing as a 300. We just have to adjust the signs. Okay, those are the only really three that we know. Okay, so we're not going to include 90 in here because it's really just a multiple of 30. Now, we're probably still better with degrees than we are in radians. Okay, so let's look at these guys in radians. Pi over 30 is a sixth. 45 is a pi over 4, and 60 is a pi over 3. So that's what's a common denominator for all of these, and that answer is going to be 12. Okay? Keep that guy in mind if you'd like to use fractions with this stuff, or you can convert to degrees if that's easier for you. Okay? Now, what we're basically going to do is take these three things here, and we can add them and subtract them to get to different values. Okay? But we need some formulas to do that. I'm not going to show you guys the proof for this. If you're interested in it, take a look in your book right in 6.4. It involves putting a couple angles on a unit circle, doing the distance formula, doing some double distributing, some simplifying, some collecting like terms, and you will get to these things right here. Okay? You don't have to have these guys memorized. You just have to be able to use them. Just understand they don't come out of some big math magic hat. Okay? So what this is saying here is it says cosine of alpha plus beta. Okay, so that's two different angles. Sometimes you may see this written as cosine of A plus cosine of B. So that's a B. That's the Greek letters for it. And sometimes we just put the alphabet that we're used to. Okay, but we're taking two different angles. That's why they have different variables there. We can add them and we can subtract them. For a cosine, the way the proof works out is this formula. Cosine of the first one times cosine of the second minus sine of the first times sine of the second. So cosine of adding angles is a subtraction. And cosines are cosine, cosine, sine, sine. Cosine subtracting angles is the exact same formula. The only difference is this negative sign here becomes a plus sign here. So that deals with the proof, and an extra negative is why that guy is that way. Okay, so you can remember cosines are cosine, cosine, sine, sine, and it's opposite. Okay, but you just have to be able to use these. Okay, so what we're gonna look at are things like this. Find the exact value of 105 degrees. Now, I don't want you just to go to your calculator and say, put this guy in degrees and say, okay, well, cosine of 105 degrees should be negative 0.25. Okay, it doesn't do you any good. You can use your calculator to help you check things. Okay. Now, 105 degrees, we know is over here, so that makes this, what, a 75 degree right there. Cosines are negative in this quadrant. That's why that answer came out as a negative. But what we can do is we can add or subtract the angles that we know to get to 105. So right now, you only have formulas for cosine of A plus B, cosine of A minus B. A couple different ways you can get to 105. Okay? I'm going to do it this way. Cosine of 60 plus 45. Okay, and it's got to be written in parentheses like that so it matches up to this guy right here. Now, that's not the only way you can get there. So think about if you can take something else that you know and maybe subtract to get to 105. But you're going to get the same answer that we will here. Okay? So all we got to do, plug this into our formula. So it's cosine of the first one times cosine of the second one. Cosine, if it's an addition, becomes a subtraction, and then this becomes sine of the first one, sine of the second one. Now, it wouldn't matter if you switched the order of these and said 45 plus 60, because all that would happen, these two would switch, these two would switch, but it doesn't matter what order you multiply two numbers. Okay? Your answer is going to come out the same. So I'm just going to keep it this way. All we have to do now is go evaluate this. Cosine of 60, so it may not hurt to draw a triangle in. If here's a 60, 2, square root of 3, and a 1. If you're using a bigger angle, make sure you get your quadrant right and you get all your angles and everything. So cosine of 60 is 1/2, and I'd write the fractions like that. Cosine of 45, we know those are square root of 2 over 2. 45s are always nice. Sine of 60 now. So we come back to our triangle. Square root of 3 over 2. Sine of 45 is the same as the cosine of 45, square root of 2 over 2. All we got to do now is simplify this. Multiply fractions straight across. Square root of 3, square root of 2 is the square root of 6 over 4. Put your answer together. And that's it. Don't tell me that this equals, negative square root of 4 over 4. Okay, you can't subtract square roots unless they're the exact same thing underneath. So don't tell me that guy. Tell me that finished guy right there. That's the answer I'm looking for. But we went and did it in our calculator, so you should be able to check. So if I take a square root of 2, I subtract the square root of 6, make sure you hit enter now, and then I divide this guy by 4, I got the exact same answer I did using my calculator. So you can use this to make sure you're going about in the right direction. Okay. Now I could ask you any combination of the angles we're looking for. So we could have done 75 degrees, and instead of the 60, it'd be a 30. Follow the formula, different values. Okay, so you're going to see very, very similar type answers with these. Here's all the work from the book. If you wanted to look at it, it's the same thing we did. All nice and neat there for you. Okay, we looked at the cosine sum and difference ones, so now we can look at the sine. Same idea. You can look in your book if you wanted to get proof for these guys. Distance formula, a lot of double distributing, simplifying. It's good to look at, but I'm not going to take time here and go over it. Maybe we'll look at it some in class. Okay. Now, if we want to do sine of alpha plus beta, so remember, it may be written on your yellow sheet, or you may see it on something as an A plus a B. Sine formulas come out a little bit different, the way the proof works. It's sine in the first one, cosine second, plus cosine first one, sine second. So whereas the cosine formula was cosine, cosine, sine, sine, signs are mixed up. Okay. Now, sine of addition does have the plus sign in there. Okay. Here's your sine difference formula. Sine first one, cosine second one, minus cosine first one, sine second one. So the sine subtraction formula also keeps a negative there as well. Okay, so part 2, we'll look at how we actually use this guy.